Hello everybody! I'm sure you know the situation. You want to record your next set, but your recording computer is far away. So in this video, we're going to control our DAW through a standard web browser. So you can just hit record and start playing. So let's get to it. Okay, so before we dive into the installation procedure and the code itself, let's have a bit of a high-level view of what we're going to do here. So the idea is that within your LAN, so your local area network, any device can now access your computer to control the DAW. Now, what happens under the hood really is that your DAW program will have control mechanisms through MIDI. It's called MackieControl. And I have an extra video that explains the details of this MackieControl algorithm that we'll use to control the DAW itself. We'll create a virtual MIDI port with a small little program called Loop MIDI. And that virtual MIDI port we're going to use then for our server to control the DAW with. The server is all written in JavaScript. We're going to use a program that's called Nodejs for the programming and running of the server code. And in essence, it has two important files. The first file is server.js that takes care of all the MIDI handling towards the DAW. And then there's the index.js, which basically is the front end towards the mobile device. So whatever tablet, mobile device you have with the browser, if you then insert your IP address of your DAW, you will get the control commands that you define in index.js. All right, with that said, let's dive in and install this code. We'll start off with the GitHub page where you can download the code. Link, of course, in the description below. So we'll go ahead with code and then download zip. All right. So then we're going to unzip the program. And that's in essence the server code. Now, in order to be able to run the server code, we need to go through the installation procedure. So we can see the installation procedure down below here. First, we'll have to install Nodejs. That's really where we can run this JavaScript code in. So we'll navigate to Nodejs and download the latest version. After installation of Node.js, we now open a command window and navigate to the folder where we just unpacked the program we downloaded, the DAW controller program. It's very important that you are in the directory where server.js is located. Only then the packets can be installed correctly. There's three packets that we need to install. The first one is a packet called Express, and we install this by typing npm install express as so. The second packet we need is a packet called socket.io. And finally, we need a packet that's called MIDI. But in order to install this MIDI program, we need to make sure that Python is installed on the machine. And we need the desktop development module for C++. With these two installed, we can now install the MIDI program by typing npm install MIDI. So as far as JavaScript goes, that's pretty much it. However, if we'd run the code right now, I could try it out, but you would see that it will give you an error message. Because if I do node server.js, it will tell us that it cannot find a MIDI interface. And the reason is that our virtual MIDI ports are not yet up and running. And we're going to do this by installing Loop MIDI. So as you can see here, it says could not connect to MIDI interface, check MIDI DAW out variable in the server.js file. And so we're now going to set up that virtual MIDI port. We can now cancel the server program by selecting Ctrl C, sorry. With Ctrl C, you can abort then the server program. Here on the website, to install Loop MIDI, that's the program we're going to use to make the virtual MIDI ports. We just click here and go to the site from Tobias Eriksson. And here on the right, we click Download Loop MIDI. I've already downloaded and installed the program. And if you run it for the first time, you will not see any ports at all. So you just see a blank page like this. Now we're going to create two loop ports. The first one is going to be DAW in, and the second one will be DAW out. The reason I use two ports is that Loop MIDI is actually meant to loop MIDI messages back, as the name implies. And so we need two. We need to have the output separated from the input. Actually, if you have a real virtual MIDI port, as you could make it on an Apple or a Linux machine, then in essence you can use the same name. But if you use Loop MIDI, two names need to be used. If I now rerun the code, it will say straight away navigate to localhost, and it's up and running. Okay, so let's do this. We open a browser window and go to localhost. Straight away you'll see the knobs, the control knobs. So play, stop, record. The one thing though is that if I press play or stop or record, nothing will happen. And the reason is that, of course, I didn't start my DAW yet. So let's start my DAW. The DAW I'm using is Ableton. Now you might be using a different DAW, but that doesn't really matter. They all have this control capability built inside. This is the DAW environment of Ableton, and if I go here to Preferences, and there in the MIDI section, you see that there's 6 control surfaces that we can now configure. The control surface protocol that we're using is, as I already mentioned, the MackieControl algorithm, so that's over here. As input, we'll be using DAW in, and as output, we'll be using DAW out. And that's all you need to do. So now, if I put this window over here, and I press now play, you'll see straight away that it starts playing. Or stop, and it stops, or record, and it starts recording. So it's as easy as that. But the one thing you'll notice is that I have in the address bar here on the top, I have referred to as localhost. And that won't work if you now try this on your cell phone. On your cell phone, you need to use the IP address. And so if you want to know your IP address, just in the command window, you can select ipconfig/all, and it will give you the IP address of your LAN network of that computer. And in fact, if you just, instead of the local host, just provide the IP address on your own computer, it should work just the same. And the fun thing is, you can now take your phone out and do exactly the same. So you put in the IP address, and as you see, there are the same control buttons. Now let me put the windows a little nicer. So we have here the Ableton in the background. We have a window over here, and then there's the buttons. And if I now press play over here, let me see if I can navigate there, then you'll see that not only does Ableton start playing, but also the other remote control updates the status as well with play, stop, or record. That's very loud. So this way you can have a universal remote control of your DAW that synchronizes throughout all devices. So in this last section of the video, I briefly want to run through the code and enable you to expand on it, add more functionality, make it to your liking. And we'll start with server.js. This is the main file that you run the program with when you type in node server.js. It starts out with 3 configurable parameters. The first 2 parameters, MIDI DAW out and MIDI DAW in, basically define the names of the virtual MIDI channel that we defined in loop MIDI. The third one, debug, is a simple boolean that you can send where when you then run the code, it outputs a little bit more data. So if you now run the code, it will tell you the DAW output name and the DAW input name used of the virtual interface. And if you select a button, it will also show you all the MIDI information it receives. If you see a command with M in front of it, this is a MIDI command received from the DAW. And if you see a command with 144 here in yellow, those 3 bytes, those are the 3 buttons that we have from the controller back to the DAW. I'll leave this off for now. If we continue, here's some internal parameters. The Express library that we loaded first to get the program up and running, then the Socket.io library, and here below also the MIDI library. Let me just describe the need for this Socket.io library. So this is the connectivity diagram of this program. We use this virtual MIDI ports to communicate with the DAW, and server.js is the file we describe right now. Clients that input an IP address though, they will go to index.html together with index.js. Whenever you press a button, the server needs to know that a button was pressed. Similarly, whenever a MIDI message is received, the server needs to parse this information on to index.js. And we're using WebSockets to do this. And over here, you can see that Socket.io is loaded, and this is then to be able to set up WebSockets between the browser and the server. The web browser is located in the public folder, and thus here this folder is defined. And we refer now to the browser. We set up here the client file, and as I already said, that's index.html, and index.html then refers to the JavaScript, the associated JavaScript file. And this last command here starts the server and listens at port 80, and that's the standard port for a browser to address when you type in the IP address or when you type in on the same computer localhost. So localhost really works only if you test it on the browser where you're running the server on as well. Now we need to set up the MIDI input port. So this is the MIDI input of our server.js. And we do that by scanning through the MIDI inputs and selecting the virtual MIDI channel that we defined. There's one thing though to note, and that is if you look carefully, you'll see that I have here MIDI DAW out as variable. The reason for that is, of course, we need the MIDI out of our DAW to communicate with the MIDI input of our server. So don't get confused by that. Then if it finds the right port, it connects to it. And if it doesn't, it outputs an error message that you should either check the variable or make sure that your virtual MIDI is up and running. Then the similar fashion we do the MIDI output. So it scans through the MIDI output ports and then connects to it when it finds the one with the right name. But connecting to the MIDI ports isn't sufficient. We need to set up callback functions. A callback function basically reacts to messages received. So whenever a MIDI message is received from the DAW, it runs a certain amount of code. And whenever a button is pressed in the browser, it runs a different set of code. So the upper one here is for whenever you press a button in the browser, that it reacts accordingly. And the lower one is whenever a MIDI message comes in, that it then forwards this MIDI message to the browser. And let's briefly see how that works. And as a fresh up, let's have a look at the MIDI messages. So I use this one more often. It's the general way how a MIDI message, a standard MIDI message, is spelled up. We have the type of message, a MIDI channel, and then there's 2 data bytes, if you will. And typically it's, for instance, the key or control message, and then the velocity. Now, this is the general MIDI structure, but with MackieControl, it is used in a different fashion. These nodes are then used to control certain parameters of the DAW. And so I'd like to refer to my MackieControl video for more information of how this really is set up. But for now, it suffices to know that when I send a stop message, for instance, it will be 144 will be the status byte. Then the data byte, let me briefly look here. The data byte would be 94 for play, 93 for stop, and 95 for record. And the third message will be somewhere between 0 and 127. And again, the definitions are in the MackieControl protocol. Okay, so let's start now with the callback function for when a MIDI message is received from the DAW that needs to be forwarded to the web browser. Basically, the only thing it does right now is it checks if the message length is 3 bytes, because MIDI is 3 bytes, as we just saw, standard MIDI messages at least. And if it is, it forwards it to the browser. But 2 things here. I could, of course, so the MackieControl sends over lots and lots of data. So it kind of spams the browser, if you will. Well, the browser, the interface to the browser is rather quick, so it doesn't really matter so much. But I could here also filter, make an extra filter and just filter out only MIDI messages that start with 144, because those are the ones that are needed for the 3 buttons. But I think it would be nice to add buttons later, maybe skip forward a measure, skip back a measure, perhaps even volume sliders for all the channels, etc. So that's why I left it open and just forward everything to the browser. The one thing that I don't forward here yet are syslix messages. There the length is typically 64 or 9 with MackieControl. So we would need to add another if statement in that particular case. The last thing I'd like to note here is that using WebSockets, you're sending over basically values. And instead of sending over 3 bytes, I combine the 3 bytes together into one integer that is then 24 bits long. And I do this with a simple MIDI to int conversion. So you can see what it does. It takes the first byte and just left shifts it with 16 bits. I left shift the second byte with 8 bits and leave the third byte as is. So that's how you get to a single integer with 24 bits. Of course, I do then the reverse action at the browser and go back to 3 bytes to then see what the message really is. The function, whenever someone presses play, stop, record on a phone or browser and it needs to be forwarded to the DAW, is over here. It's basically the reverse function. We get a 24-bit integer from the phone, split it up here to a MIDI message, and then send it out to the DAW. And that's all there's to it. Of course, there's then the reverse operation from a 24-bit integer to 3 bytes. And that is here shown over here. And that's all there is in server.js. So let's move over to index.html. Index.html is basically what a user sees when they type in the IP address of your DAW. So here only 3 images are loaded, play, stop, and record. and per default stop is enabled and the others are not. And we load the socket IO, of course, we need to be able to communicate to our server, and we load index.js. That's all there's to it in this HTML. So you guys can go add fancy CSS style sheets and extra buttons and you know what. And if you do, let me know, send me a version. I'd love to update this. Okay, so let's go to index.js. Here, I first define the images used. Instead of writing the images out all the time, we can just refer to play as SCR 0 or 1 for when it's off or when it's on. So then here we have these three get element by ID, and these are needed so that whenever someone presses those buttons, we can run some JavaScript. So play, stop and record, and then you can see here play at event listener. So that means whenever someone clicks, run this code. The first line here is prevent default, and that means HTML, don't do anything. JavaScript will take care of it. The next item is that whenever someone looks into the console, you see that play is clicked, and we then do socket.emit, so basically transfer a message to server.js, if you will, and that message is called Midi, and the value is one integer, 124-bit integer, that is 144.94.1, and that is basically the MackieControl way of saying play. Or in case of stop, it's 93.1, or in case of record, it's 95, and then 0 or 1. Okay, and in a similar fashion, if we receive no messages from the server, we receive some, we listen to messages that are identified with the flag Midi, and then convert these back into bytes with the int to Midi function. So this is then called message. We look into the first byte, and if that is 144, and if the message is 95, then we know that someone pressed the record button. If it's 93, we know someone pressed the stop button, and if it's 94, we know someone pressed the play button. Whenever these buttons are selected, then we switch the picture accordingly and make sure that the browser is up to date. And so that's pretty much it. There's here a general function to switch the icon of the button that we're using all the time. And there are the two functions here to convert the 8-bit MIDI messages to 24-bit integer and back. And I left this last one in for fun to just check if someone's using a mobile phone. You could use this to optimize the display of your HTML if someone has a mobile phone. At the moment, I don't use this. Okay, so that's about it. I hope this is instructive, and especially that you can really use this code to expand on it. The Mackie protocol is really powerful. So add, for instance, the display of the individual channels, panning between the channels so that you can walk around your room and make your final mix from different positions of the speakers. You can add navigation buttons to go measure forward or measure back. Basically anything that you can do on any MIDI control board, you can now do through a standard web browser. I hope you liked this video. I very much look forward to reading your comments and seeing what you do with this code. If you do expand on it, let me know. And as usual, likes are well appreciated, and see you in the next video.